Hello everyone, in this video I will show you how I use the sound card on my PC to test the microphone preamp and equalizer and make some charts like the one that you're seeing here on the background and analyze the response of the device. Welcome back to the channel, and if this is your first time here, this is Pablo, Equalization VA3 HDL. How all this started? A couple of weeks ago, I came across this video from Andreas Spias, is a ham radio operator from Switzerland, and he uploaded this video about how you can use the sound card in your computer as tool, like an oscilloscope or spectrum analyzer. And then I looked entirely at this video and did a little bit more research, and the software that it was presented in this video is the Room Equalizer Wizard, which I'm gonna open here. I have it here installed. This is the software I use, Room Equalizer Wizard, and I have few recordings of the tests that I done on the preamp and an equalizer, the DSP for the preprocessor for the microphone for all radios, and this is it's a program that is not very user friendly. Let's put it that way. It takes a little bit of learning how to use, but it's incredible the power that it has for free. Right? This is a not cost. It's a free software that you can run, and I'm gonna show you how I set up in my environment. And once you have your sound card calibrated, you can start running sweeps on any device that has an input and an output of audio, and you can see the performance of the device under test. So the first step to use this software, you need to calibrate your sound card, and in order to do that, you need to connect together your input and your output, like a kind of a crossover, like I done here with these two short leads. So I'm lucky my keyboard, it has an extension from the sound card coming out in the back of my computer. So that comes directly into my keyboard, and the keyboard has two jacks connection in the back where you can plug these short leads. So for the calibration purposes, I just connected the inputs and the outputs and run the calibration on the Room Equalization Wizard software. If you want to learn how to do that, I suggest to watch the video from Andreas. So once your sound card in the computer is calibrated, you need to run another sweep to check that calibration. And if everything goes well, you can see the output, like the red line that I have here in my output. Once it's calibrated, the output coming into the input of the computer, it should produce a flat line like the red line in here. So in this example, the device under test is this simple isolation transformer that I use a lot on all my projects. So this is a 600 ohm to 600 ohms one-to-one isolation transformer, and in this case is the device under test. We use one channel to test the transformer, and the other channel is connected straight from the output into the input for the reference in the software. In this screenshot, after the sweep is run, so we can see two lines in here. So the top line is our reference line, is the sound coming straight from the input into the output. And the green line is the sound coming through the isolation transformer. You can see there is a variance in between 13 hertz and about 80 hertz, and after that is pretty flat from 100 hertz to 20,000 hertz or 20 kilohertz. Is pretty flat, and we can see that the transformer has a little bit of loss only on the low frequencies, but then after 1K, 1 kilohertz and up, there is almost no loss on the transformer, and the response is pretty much flat across all frequencies from the audio spectrum. And this is kind of an experiment that I tried. I inverted the connections on the transformer just to see if I can see that on the software, like in a different phase in the input and output, and this is the result. So as expected, the phase is 100 degrees, 180 degrees difference with the input, because the inversion of the connections in the transformer. So the red dotted line at the bottom is showing the phase in each phase and in each frequency of the spectrum. And at that point is at 1 kilohertz is 180 degrees offset with the original input phase. So now let's jump into testing the preamp, shall we? The previous test that we done has been just to make sure the environment is set up properly to run this test. Also, I wanted to make sure the isolation transformer, it didn't have any implication in the putting in between the equalizer and preamp. Right? And as you can see here, the output of the computer is directly into the isolation transformer, and the output of the isolation transformer, it goes into the microphone input of the preamp. And the reason of that is I didn't want to connect directly the output of the computer, of the sound card, into the microphone input of the preamp. Like, I will not do that on my radio. I didn't want to do it in the preamp directly. So that's the reason I am using that little isolation transformer on the input. There is like a brown, orange, pink cable that goes directly to the back. That is the reference line. This is the other channel that we don't use. We always test this one channel for the device under test, and the other channel goes straight input to output or output to input to provide the reference. And this is just a close-up of the connection from the output of the sound card into the microphone input of the preamp equalizer for the microphone. And after I ran the first scan, or surprise, I got this not very nice output. And this is how the equalizer performs after the power up. So this chart, this graph that I was able to obtain using the testing environment that I described, it helped me to confirm a suspicion that I had. Then when the device is powered on, it doesn't get initialized properly. And this is how it looks like, only turning on and off, like resetting the equalization options from the menu on the device. So there is something in there at the beginning that is not set up properly, and by turning the equalization on and off, it set up the DSP properly. So now I'm gonna run a live sweep of the device, so you can see how the software performs when it's running the sweep. On the screen, there are two yellow lines. The top yellow line is the peak meter for the input, and the shorter yellow line below that is the peak meter for the output. And this was a very nice swept with the proper input level to don't saturate the input of the preamp. So now the swap is completed and now it's finished, and we have the finalized curve for the response on that swap. In the next swap, I'm going to increase the level 6 dBs from -18 to -12, and we will see now that with that level, the yellow line is peaking. I'm talking the yellow line on the mirror on the preamp. It's peaking all the way to the right. That means that is a very high input, and we will see that how affects the output. Now the swap is finishing, and we can see in green the distortion on that part of the spectrum. For the next run, I turn the auto makeup gain into the preprocessor for the microphone, and always running with an input of -18 dB. You will see on the screen how the variance that we have in the input is not affecting the output level. Those are the two yellow lines that are mentioned on the display of the preamp. So now at the end, the yellow line on the top, the input, it was lower, and you saw in there that the output was still always remaining in the middle of the screen. In this test, now I'm going to show a live spectrum display coming from the output of the equalizer, the preamp equalizer, and I'm going to turn on the noise gate. And as soon as I turn on the noise gate, you will see the white, which is the live output of the preamp, how it immediately goes down and to a flat level, and in red is possible to see the old noise level. Now in this test, what I am doing, I am running a test for specifically 3.3 kilohertz equalizer setting of plus 12 dB, and when I turn the equalizer on, immediately you can see the response on the screen for that increase in gain for that particular band, for that particular frequency. I am injecting on the input at 3.3 kilohertz tone. That is the window that is at the right on the screen with the -35 dBb volume. In the next test, instead of running one specific tone, one specific frequency, I'm running a small sweep between 2 kilohertz and 4 kilohertz. And I'm running the spectrum analyzer. And then I turning on and off the equalizer for the 3.3 level, just to show that increase in gain when the equalizer is on for that particular band. For this next test, I run a frequency sweep from the entire audio band, from around 100 Hertz to 20 kilohertz. And I start with the equalizer off. And this is very interesting. This is something that only with a tool like this you can identify and understand if what you're hearing is correct. As soon as I turn the equalizer on, I immediately notice that the audio level drops about 20 dBs more or less from the original peaks. The original peaks are in red and the current level are in white. And you can see that difference as soon as I turn the equalizer on. So what the equalizer does is not only create a passband from between around 150 Hertz to approximately 3.3 or 4 kilohertz, but also is lowering that entire passband level about 20 dBs. So what this does is that creates a headroom for increasing the gain and specific frequencies. Now in this particular test that I'm doing, I start with the sweep with the equalizer on. And this is a custom sweep that for the entire audio band that goes from 100 Hertz to 20 kilohertz. And I'm focusing on the 1.3 kilohertz frequency. So at that point, I move from minus 12 to plus 12 dB to show how is the response on that particular segment of the equalizer. As you can see on the screen, you will see the peaks increasing at that particular 1.3 frequency. Now in this test, I focus on the same frequency, 1.3 kilohertz, and I start at 0 dB. And this is something that I cannot explain. Going down to minus 12 dB, you see right in there that the levels increase for some reason instead of going down. So instead of being minus 12 dB, now it looks like it's plus 12 dB. And at the same time, when now I turn back to 0, it goes down. And once I go above 0, it goes up. So it's something that I don't know if it's a glitch on the code or what it is, but it doesn't make sense to me. Only you can identify those things with doing scans like this, having a tool like this that you can see on the screen the result of your interaction with the device when you're changing the settings. And that's all, folks. I hope you like the video, and if you do, please don't forget to click the like button, subscribe, so you get notifications when I upload a new video. Until the next time, thank you so much for watching.